All right, mathletes, here we are looking at equations of a line. So, first form of equation of a line we're going to look at is our gradient-intercept form. It's called this because our m is a gradient, and that is the coefficient in front of our x, and the intercept is the y-coordinate at which our graph is going to cross our y-axis. Okay, and that is given by our c value in our equation. Okay, so in an example here, if we have a line L passes through the point A17 and has a gradient of 5, find the equation of L, give your answer in the form y equals mx plus c. So remember, equation of a line is just giving you a solution set of points that satisfy a single linear condition. Okay, so given that my gradient is 5, okay, I can go ahead and plug that in as my m. So what I get is y equals 5x plus c. So the only thing I have left to figure out to finish this is my c. Well, conveniently, I have been given a x and a y value that must be satisfied by this equation. So by substitution, I can plug in my x and my y into my equation. Okay, so I get 7 equals 5 times 1 plus c. Okay, I can solve for c. So by simplification, I get 7 equals 5 plus c minus 5 minus 5, and I get 2 is equal to c. So I have my m value. I now have my c value. So combining these together, I get my equation of a line. Y equals 5x plus 2. Okay. So I can tell my gradient is 5 and my y-intercept is 2. All right. So so here's another example. So our line L has a gradient of 1/3 and passes through A to -1. So I can graph to -1, remembering 2 is my x parameter, -1 is my y parameter. So I'm going to graph the point right here on my graph, and I'm going to label that A. Okay, because I have a gradient of 1/3, I can think of gradient as rise, 1/3 as rise over run. So I can go from my point A, go up 1 over 3, and I have a point there, up 1 over 3, I'd have a point there. Well, I can also know that 1/3 is analogous to -1 over -3, so I can go down 1, backwards 3, get a point there, down 1, backwards 3, get another point there, another point there. And then every single non-integer value in between, and I can graph my line, and I'm going to have something like that. Okay. So just to kind of get a visual idea, so I've actually already finished drawing my line here on D, but what I want to do is first find the equation of L, give your answer in the form y equals mx plus b. So just like before, I can say that y is equal to 1/3 x plus c using my gradient that was given. Now I'm going to use my point to -1 and plug that in for my x and my y. So now I have the equation -1 is equal to 1/3 times 2 plus c. So I have an equation. So now I have one unknown, so I can solve for my c value. So I simplify this. So I get -1 is equal to 2 over 3 plus c. To get c by itself, I'm going to subtract 2/3 from both sides. So it's minus 2/3. Okay, so I get equal c. Okay, these cancel out because they're opposites. Well, if I'm subtracting fractions, I want to get a common denominator. So I have a denominator of 3, so I'm going to multiply this by 3 over 3 to get my common denominator. So -2 over 3 minus 3 over 3. Well, I know that's the same thing as 1. And then I'm going to see that negative 2 minus 3 is negative 5 over 3. And that is my C value. So now taking these two pieces, I get y equals 1/3 x minus 5/3. Okay. B, write down the point of intersection of L with the y-axis. So luckily, I know my y-intercept is right here, so that's where it crosses at negative 5/3. Okay. So my part B is negative 5/3. Okay. So C is asking, find the point of intersection of L with the x-axis. So remember, x-axis, my y, is equal to 0, right? So I want to know when y is equal to 0, what is my x value? So I have an idea from my graph, so what I want to do is substitute y in for 0. Okay, and I have 0 is equal to 1/3 x minus 5/3. So now I want to solve this for x, so I get the x value. So I notice that they're both dividing by 3, so I'm going to multiply this entire side by 3. Multiply 0 by 3 the other side, and I see that I get 0 is equal to x minus 5. Adding 5 to both sides, I'm going to see that I get x is equal to 5. Okay, and again, I can verify that idea that x is equal to 5 on my graph, right? And this is my x-intercept. Okay, and again, connecting all these ideas together, I see I have my slope of up 1/3. I see that my y-intercept is here at negative 5/3 is my y-intercept. And that's it for that example. So let's go to the next one. Okay, so the next thing we're going to talk about is general form. So sometimes an equation of a line is going to be given to us in our general form. We're going to be asked to give it in our general form. Big thing to notice about general form is now our x and y variables are on the same side. Okay, we have a c variable, which is just a constant, and it's all equal to 0. Notice, big thing here to satisfy these conditions, that a, b, and c must be within our set of integer values. So they can be negative, they can be positive, but they must be integers. Okay, so let's go ahead and look at an example here. So line L joins the point A, negative 3, 5, and the point B, 1/2. Find the equation of the line L. Okay, give your answer in that general form. Okay, so first thing I'm going to do is, if I'm given 2 points of a line, I'm going to realize that I can go ahead and put that into my slope-intercept form. Okay, and in order to do that, I need to find my slope. So my m is equal to my rise, so y2 minus y1 over x2 minus x1. So I'm going to just call this my first point. So this is going to be x1, y1, and then this b point is going to be x2, y2. Okay, so as I substitute those in, I'm going to get 2 minus 5 over 1 minus negative 3. So as I simplify this out, I get negative 3 over 1 plus 3 is 4. So I get a gradient of negative 3 over 4. Okay, and then I'm going to plug it into my y-intercept equation. So I get y equals negative 3 over 4. Okay, x plus c. Okay, so from here, I'm going to go ahead and I can plug in my x and y just like I did before. Okay, so this is mathematician's choice. So you can choose point A or point B. I'm just going to go ahead and choose point B. Okay, so point B is going to be my x is 1, my y is 2. So then I have the equation 2 equals negative 3/4 times 1 plus c. Okay, so 1 times my fraction is going to be the same, so 2 equals negative 3/4 plus c. Okay, and I'm going to go ahead and add 3/4 to both sides. And add 3/4. So I get 3/4 plus, I want a common denominator, so I'm going to multiply this by 4/4. So I get 8/4 is equal to 11/4, which is equal to my c value, because this side canceled out. So on my final equation, combining these two ideas, I get y equals negative 3/4 x plus 11/4. So now this is slope-intercept form, but I want to make sure I put it into my general form, which means my x's and y's are on all sides and they're all integers. So first thing I'm going to do is get them to all be integers, or all my coefficients to be integers. So I'm dividing by 4, so what I'm going to do is multiply both sides by 4. So what I'm going to get then is I get 4y is equal to negative 3x plus 11. So I got rid of my fractions. Last piece is to shove everything over to one side. So I'm going to add 3x, get the right side equal to 0, minus 11. Do the same thing over here, plus 3x minus 11. Typically our x terms go first, so I get 3x. Then my y term is going to be plus 4y. And then I get minus 11 equals 0. So there is the equation of the line in general form. Okay. Part B says a point 5,3, comma t lies on L. Find the value of t. So using all this information, okay, I'm going to go ahead and use 5/3. And so this is my x value, and this is some unknown t. So I can plug those into my equation. So 3, my x is known as 5/3. Okay, and I get plus 4. I'm going to solve for the y value, which we're calling t, minus 11 is equal to 0. So now I'm going to isolate the t value, so I can solve for t. So pulling away my layers and simplifying things, 3 times 5/3, those cancel out, so I get 5 plus 4t minus 11 equals 0. Collecting like terms on my left side is going to be 4t minus 6 is equal to 0. Okay, adding 6 to both sides, I get 4t is equal to 6. Dividing by 4 on both sides, okay, I get t is equal to 6/4. Noticing they both have a factor of 2, I can simplify my fraction and get 3/2. Okay, so I get t is equal to 3/2. Okay, so also with equations of lines, we need to understand we can have vertical lines and horizontal lines. All vertical lines are going to fall under the format of x equals k, where k is some constant of where that vertical line is. Remember, vertical lines, you just need to tell me how far left and right that vertical line needs to be, and that left and right parameter is x. Okay. The other type of line here we're talking about is horizontal. So the horizontal line, right, is going to be always of the form y equals k, because a horizontal line, one in the blue, what you need to tell me is how far up and down it is, and that up and down value is my y value. Okay, so here in this example, I can see that my vertical line is going to have the equation x equals, so my y values are always changing, but what's always the same is that my y value is, or my x value is -4. So that is the equation of that vertical line. My horizontal line here in the blue, I notice that they have different x values going left and right, but it always has the same y value, so my y value is always equal to 7. Okay. Our last concept here is understanding that Lines are always going to intersect. The only time we have lines that don't intersect is if they are parallel. So in order to find two lines that intersect, what we are going to do is we are going to put them into the y equals mx plus c form, and then set them equal to each other, and then solve it out algebraically. So let's look at our last example here. So find the point of intersection of the lines y equals 2x plus 1 and negative x minus y plus 4. So first thing I want to do is make sure they are in gradient intercept form. So the first equation, check we're there. Second equation, we're in general form. So we want to rearrange this to put it in the correct form. So the way we can think about our gradient intercept form is our y is by itself. So we can just add y to both sides. Okay. I'm going to get negative x plus 4 is equal to y. So just by the symmetry property, I can say y is equal to negative x plus 4, and therefore now I'm in the correct form. Since these are both equal to y, I can set them equal to each other. So I get 2x plus 1 is equal to negative x plus 4. So I'm going to collect my like terms. I'm going to get x's over on the left side. So I'm going to add x here, and I'm going to get my constants on the right side. Minus 1, minus 1. So as I simplify things, these cancel out. 2x plus x is 3x. X's cancel out here, and plus 4 minus 1, I get 3. So dividing both sides by 3, I get x is equal to 1. Okay. Now, since it's a point, I also need to know my y value. Well, I can find a y value by plugging it in to either one of my equations, either that equation or that equation. So I'm just going to pick the first one, and I'm going to say that y is equal to 2. Well, my x value is 1 plus 1. So I get y equals 2 plus 1 is equal to 3. So my point is 1, 3. I can verify this by the other equation. So I can see that if I do negative 1, so using this one, negative 1 plus 4, and I simplify that out, that is equal to 3. Again, the same y value. So that point satisfies both of my equations.